So a lot of effort can go into optimizing Quicksort, but one of the issues that I mentioned, right, is that if we got this as our input, right, if we got something that was, right, if we got something that was pretty much like reverse sorted, right, this isn't completely reverse sorted, but it's close, right, if we choose a pivot value, this is going to be our pivot value, and everything's going to end up being less than that value, than our pivot, right? And so we've only successfully partitioned out like a single item out of this side, and so it doesn't make for a good Quicksort. You know, it means that basically we haven't optimally split into our layers. Now, ideally, the value I would want to choose on this side is the median value. But finding the median value, try it, it's actually slightly difficult to do efficiently. I want to do it in the minimal amount of time with the minimal amount of fuss. And rather than doing that, instead what I'll do is that I will kind of cheat. I'm going to go ahead and, you know, why the median? I'd like to use the median value of my pivot. Now, which one's the median? Over here, right? 1, 2, 3, right? 4. This item would be the median because notice that it's everything that half the items are less than it, half the other items are greater than that. So, so ideally I'd like that to be the pivot. But you don't know in advance what the pivot item is what the median's going to be. Yeah, you could calculate the average in O(n) time, but not necessarily the median, right? Or the median's a bit trickier. So, so now what we're going to do here is that we're just going to kind of cheat. Right, let's go ahead and I'll give us a random puzzle over here, right? And the way we're going to go ahead and try to make sure we don't end up with a poor pivot value is that we're going to quickly find 3 values. This takes constant time to find these 3 values. We're going to find the first item in the array, the last item in the array, or list, and then the middle item, right? Middle item takes no time at all, assuming you're not dealing with a linked list, right? So this will be pretty bad for a linked list. Okay, so we find those 3 items. We sort those 3 items. Sorting 3 items takes no time whatsoever. Okay, and then we'll choose the middle item to be our pivot. And then we're assured at least some of the items will be less than our pivot. So let's go ahead and see how this works. So this is our pivot. So search up for our first item that's bigger. Okay, first search down for our first item that is smaller. Okay, swap them. Okay, search up for our first item that's bigger. First search down for our first item that's smaller. That's this one. Okay, so we need to swap down and pivot because we're done partitioning. And now we quicksort the right half, right? So now to quicksort the right half, right, we take the first value, the last value of the subarray, and the middle value of our subarray, and we sort them. Sorting 3 items is a constant time operation because we're always sorting 3 items no matter what the algorithm says to do, right? So we've got 3 items, and now we choose the middle one as our pivot. Right? Everybody kind of see how that worked? So we've got our middle value as the pivot, and now we search. So now we've got our pivot. We search up for the first item that's bigger, down for the first item that's smaller. Up and down haven't crossed yet, so we swap these 2. So search up for the first item that's bigger, down for the first item that's smaller. They've crossed, so swap pivot and down. Okay. And so now we've got to quicksort the left half, quicksort the right half. Now this is of size 2, so we can just, you know, take these 2 items and sort them. And same over here, we can take these 2 items and sort them. So we're done quicksorting the left half and right half. Boom. So that will so this will ensure that sometimes we don't get the greatest pivots, but at least we're not going to get some. But this will ensure that we're never going to get something that all the items go in one direction or all the items go in another direction. So that is Quicksort.